Yeah, today we are going to start AWS. Okay, so I'll explain what are the tools we are going to discuss and um, how to create AWS account today, and then we will move ahead. Okay, fine. So AWS Amazon Web Services, which is the cloud service where we can have all the infrastructure virtually on the browser. Okay, so actually what these guys are doing is these guys are maintaining a huge hardware equipment at their data center, and they are using their own virtualization software and giving all the services through the browser itself, so that we can just for example, if we need any server, we can just simply log into our account on browser and select the configuration what we need, and we just launch the machine. Okay, first of all, let us discuss what is cloud computing. Cloud computing provides a simple way to access servers, storage, databases, and a broad set of application servers over the internet. Okay, see, everything can be done over the internet. For example, uh, if you are working with a conventional data center and you have 300 servers, 400 servers, but you need to have a spacious room for this all the servers and air condition, and every time you need a service guy to look after that data center. Okay, it is very costly affair to purchase 300 servers, I mean hardware, and maintaining the data center, power, etc., everything. So in this case, what you are getting is you are getting simply one AWS account and you are working on your browser. That is it. Okay, that is the main advantage. And cloud computing provides you own and maintain the network connected hardware. Okay, required for these application services, while you provision and use what you need via a web application. Okay, that is what I said. Okay, and these are the locations and services where we have in cloud. One is shared resources among communities of users. There is a public cloud. That means for example, in AWS, you have both. See, cloud computing is not only with AWS. There are many other players like Azure, which is Microsoft's one, Oracle Cloud, Cyber Cloud, um, and there are many others, Rackspace, Google. But the best player is AWS, and the second best is Azure, but it is very far behind AWS. Okay, so what public cloud means is it's a shared resources. For example, if you have a uh, if you have a hardware and it is shared among the people and publicly accessed for people, so that is called public uh, cloud. If it is secured, okay, many people maintain their own private clouds also. They'll maintain their own hardware at offices instead of using AWS and Azure, which is very cheaper than what we are getting through AWS and Azure, and more secure. So they use it, um, and hybrid cloud is both the combination of public and private. For example, in the scenario, you have a web application running on Tomcat container and Apache server running on different machines. But whenever you see that Apache should be publicly available, accessible to others, where your application servers are not. So you have to mix both these public and private clouds. Okay, or for example, if you are using an application which is publicly accessible and client has his private network and you both want to use together, then you need public cloud, which is, sorry, hybrid cloud. Okay, that depends on the requirement, and it depends on the application that you are using, how secure it is. Okay, the services a cloud platform provides is IaaS, PaaS, and SaaS. Okay, IaaS is infrastructure as a service. Okay, outsource the elements of infrastructure like virtualization, storage, network, and balancers. See, if you see now in AWS, what happens is everything is a service, infrastructure as a service. That means if you want to launch a server, they give you it server as a service, okay, and storage as a service. So the platform is IaaS, that is infrastructure as a service, and platform is a service. For example, core hosting, operating system, and optional building blocks such building block services that allows you to run your own application. For example, platform as a service. If you see operating systems are there, it's a platform, Linux platform, Windows platform. They are giving it as a service, and other services like Lambda, where you can run your own web application directly on the Lambda without having any um, operating system needed. But actually in backend they run the operating system, but you don't need to understand what operating system they are running on. And for example, RDS, it is a relational database service, where normally conventionally what you have is you need to have a server. On that server you have to install your a database application, and then you will access the databases. Okay, so in this case they are giving RDS as application. You just launch RDS instance and you connect to your database without having knowledge or without needing any information of the operating system they are running. Okay, that is the advantage. And software as a service, consumed as a software only for the applications needed. There are so many softwares you can it can be available in cloud platform, and all are provided as a service. Remember that everything in cloud is a service, but you don't see physically any machine. They provide everything that you use as a service. Okay, main advantages: achieve economies of scale, increases volume output or productivity with fewer people, your cost per unit projects or product drops. See, for example, you want to start a startup, right? And you need 10 servers for your application. For example, for 10 servers, you need a office room for 10 servers, data center, and you need to maintain air condition. You need to maintain resources around the clock 365 days, right? And you have to pay for 10 machines. If you, for example, if you take a server hardware for 1 lakh, it had, yeah, it costs more than 1 lakh, but for example, if you take 1 lakh, it costs 10 lakhs for your physical machines. And if you purchase server operating system, okay, it will cost you more. And for any application you install, they will charge again and again. Okay, and it is very difficult to upgrade the machine. For example, if you want to change the capacity, for example, RAM, CPU, or storage, it costs you very much. So in cloud case, what it happens is you can simply scale it. But in cloud, servers are charged per hour basis, and which is very less. So while you are starting server, for example, in 10 servers, you are launching 10 servers. If you have Windows medium machine with 8 GB RAM and 250 storage, like that, it hardly costs $200 a month. But you are not spending every rupee at the beginning of your startup, but you are spending after a month, every month, and which is very lesser amount, right? $200 is very affordable for any startup company, right? So that is how it works. That cost depends on the capacity of the server you are running and how long you are running. And if you are not running that machine for few hours, you will not be charged. That is how it works. And reduces spending on technology infrastructure, maintain easy access to the information with minimal upfront spending, pay as you go. As I said, you spend very lesser amount for cloud, and you only pay for what you use. If you don't use that particular service, you will not be charged. Okay, and globalize your workspace on a chip. People worldwide can access the cloud provided they have an internet connection. See, for example, if you're in your organization, employees are working around the globe, and they don't need to they will not get any access problem for the infrastructure, because they'll just connect to the log into their AWS account and manage their infrastructure. So that is how it works. And streamline process, get more work done in less time with less people. See, for example, if you have 10 people or 10 servers in your physical location, I mean on-premise machines. On-premise means a physical servers. Okay, if you have 10 physical servers, you need more than 3 people to maintain round the clock. Okay, but in my company, for example, we have almost 400 servers and we are only 4 people managing the servers. So we don't need to look after the physical machines whether they are running or not. We just need to focus on our work itself. That's it. So reduce capital costs. There is no need to spend big money on hardware, software, or licensing fees. It reduces capital costs. So you don't need to invest everything upfront. So, and for software licensing and all, AWS will take care of it. So for example, if you are running a Windows 2012 data center, so you don't need to purchase the operating system to install on cloud machines. Amazon will take care of it, and that license cost will also be included in your bill with the EC2 instance itself. Okay, so you don't need to take care, and you don't put alarm to renew the license, etc. AWS will take care of it. Improves accessibility. You have access anytime, anywhere, making your life so easier. So you can access this infrastructure from anywhere. Monitor projects more effectively, stay within budget and ahead of completion cycle times. So actually your budget can be monitored. That means, for example, you can have billing monitors, so that for this month my budget is, for example, $10,000. Okay, whenever it reaches $10,000, it gives me alarm saying that it is reaching $10,000, so that I can adjust my infrastructure, so that I can control my uh, spending on this infrastructure. Okay, less personal training is needed. It takes fewer people to do more work on the cloud with a minimal learning curve on hardware and software issues. So as I said, less personal training is needed. If one person knows how to launch EC2 instance at once, he can launch anytime. Okay, it is not like assembling hardware and installing everything. It is just few clicks. But people need to understand the concept, how they are launching. That is it. So minimize licensing new softwares, stretch and grow without without the need to buy expensive software licenses or programs. Comparatively, from outside, software licenses are very cheaper in AWS because they are purchasing in bulk amount. Okay, improve flexibility. You can change direction without serious people or financial issues at stake. Okay, so it is more flexible, as I said. You can change direction without serious people, because even any simple guy, any normal guy, it is not about admins or DevOps guys. Any normal guy who is interested in AWS can operate their own machines. They can host their own websites, etc. Okay, I'll show you how. So we need to understand the basics of AWS, how it works, and what are regions and availability zones. Okay, in AWS we have regions and availability zones. Region is nothing but a geographical area where we have data centers. Okay, each data center is a availability zone, physically separated but within the same geographical location. For example, we have a data center in Mumbai. Okay, we have Mumbai region in AWS. In India, we have Mumbai region. So in Mumbai, remember this, Mumbai region, it is a region. In Mumbai, there are, I think, 3 availability zones. So these 3 availability zones are actual physical data centers. These are in 3 locations inside Mumbai. Remember that. These are 3 locations inside Mumbai. In the first image, you see it is US East region, North Virginia. Okay, that is a geographical location, and there you have 3 availability zones in this example. Availability zone A, B, and C. So in interviews, you will be asked this question like, what are the difference between regions and availability zones? Availability zones is a physical data center and region is a geographical location. In a region, there can be multiple availability zones. Okay, they are in different parts of that region, because if one fails physically, another will work immediately. Okay, so the very important and mostly used service is Elastic Compute Cloud, which is EC2, where you launch actual servers. Okay, Elastic Compute Cloud, we call it EC2, where you launch your actual servers. EC2 instance is a virtual server in the AWS cloud. You need to learn terminology whenever you are facing interview, right? So actually we don't call it as a virtual machine or server. We call it instance. Okay, instance is a server we launch in EC2. That is it, remember that. So EC2 instance is virtual server in AWS cloud. So when we launch EC2 instance, it is launched virtually in AWS hardware, and we will be able to access that instance remotely. Okay, its root volume is an EBS volume. EBS means Elastic Block Storage, where you can format the disk so that it can have file system. Okay, I'll tell you what is file system in later classes. Okay, and these instances are located in a virtual private cloud with the IP range that you specify. Virtual private cloud is nothing but your LAN or network within the cloud. You can have multiple virtual private clouds. Remember that this is a separate, isolated network within the cloud. So you can have multiple VPCs, and you can specify multiple ranges of IP addresses to the machines, and you can communicate within the VPCs like that. Okay, so here what I'm saying is VPC is a network and EC2 instance is a server. So within the network you can have multiple servers. Okay. Oh, right. So you can decide which instances are exposed to internet which remains private. That means, as I said, there are private and public, right? So in my example again, if you are running Apache as a web server and Tomcat as a web application container, so my Apache server will be exposed to internet, so that Apache is web server. Everyone should able to access this application, I mean website. And internally I access my web application from Tomcat through Apache. So this Tomcat server is not needed to expose publicly. So these two servers internally communicate with each other, and only my web servers will be publicly accessible. That means nobody can connect to the server, but they can use my website itself. Okay. So there are security groups and network ACLs allow you to control inbound and outbound network access to and from your instances. So in the picture you can see the outer line is the cloud, and that yellow vertical line is availability zone, and at the top the red line indicates, red box indicates security group, and the blue box indicates Amazon EBS volume. Okay, that means actually security group is nothing but a firewall. Okay, in Windows you can have firewall, right? Like the same way we can have security group in AWS where you allow or block IPs, sorry, port numbers, allow or block for port numbers and where you want to allow it. And also network ACLs also you mention which traffic should come in and which traffic should go out. Okay, we will see all these things in detail. And EC2 service level agreement commitment is 99.95 availability for each AWS EC2 region. So they commit 99.95%. Okay, it is not even single day for a year. That much availability we can have in AWS. It is very easy to scale up and scale down. Pay only for the uptime. So what I'm saying is, normally in companies what happens is, actually if I got a new client, I need that client need a few servers. And for example, I launched the servers with configuration 4 CPUs and 16 GB of RAM and for example 100 GB of storage. Okay, so after some actually I keep monitors for that machine. After some time I found that the servers are not even using half of the resources I gave it to I gave. Okay, in that case what I can do is I can simply downgrade the capacity of the server within no time. It hardly takes one restart time, that is it. We will change it and just restart it. I'll show you in practically in later sessions. So that is simple it is, but for the physical machine, you have to consider so many things. We have to remove the hardware, and it takes so much downtime, and hardware gets older. For example, for older machines, you will not get any hardwares to upgrade in market. Okay, that is a problem you face, and pay only for the uptime. How long your server is running will be charged as per hourly basis. But if you shut down the machine half of the time, you don't need to pay for it. For example, I'll give you one example. If you are running a business in India and you are running 50 servers. Okay, for example, say website. You are running a website which need 50 servers. But actually, more people use only in daytime, and you don't need those servers running in nighttime. Okay, so normally why people run more servers is to balance the load, right? Yeah, for example, say Flipkart. People are using Flipkart all the daytime, but in nighttime, most people do not come, right? In that case, I'll shut down off of my servers in nighttime, which saves cost for me. I keep the website running on few servers because if someone logs in to purchase anything in night time, they can use that. But I don't want to run. I don't have load in night time. In that case, I shut down the servers so I can save money. That is the main advantage of EC2 instances. And we can have auto scaling option as well in EC2, for example, servers are provisioned automatically depends on the load. For example, I have one server. I configure a launching configuration and auto scaling group such a way that if my CPU utilization reaches 80%, launch another server. If it reaches 50%, shut down the additional server. So when I set this rule, I only initially, if there is no load, initially I run only one machine. Whenever the load increases, it automatically launches a new machine and add it to load balancer. So that, for example, if Flipkart is running any uh, offers for a day, so many people are coming into uh, Flipkart site. In that case, what you have to do, you need more servers. But launching every server manually according to the load, you cannot do that. Okay, you can automatically scale it. That is called it is auto scaling. Okay, we are going to discuss in detail about auto scaling. So I just want you to understand the concept, how we increase the number of servers so that it will be beneficial for our clients. Okay, and virtual private cloud. As I said, a virtual private cloud is a virtual network like a traditional network with the scalable infrastructure. Okay, in this network, in this diagram, if you see that the vertical line, the second one in blue or black, yeah, is VPC, and within VPC we can have subnets. Subnets will communicate through a router. Okay, a router is not physical router. There is a routing table. We just mentioned these subnets inside the routing table so that these two will communicate. As you observe, subnet 1 is an availability zone A and subnet 2 is availability zone B. That means if you have two availability zones in your region, you can spread this network among these two. What people normally do is if you have two web servers, they'll create one web server in subnet 1 and one web server in subnet 2. Because if the physical data center availability zone B fails, your site will not be down. Okay, because A will be running. That is how it works. Okay, and subnet can be configured within VPC. You need to understand basic concepts about IP addressing and subnetting to understand this. Okay, you can have a VPC with several EC2 instances spread across multiple availability zones in single region. Okay, you can route traffic from one VPC to another VPC by establishing VPC peering. We'll see. Uh, yeah, in next slide we will see how we have VPC peering. It is just like that, how to connect two networks. Peering is nothing but how to connect two networks. Okay. So this is the typical diagram of a virtual private cloud. Okay. From the top you can see you have instances. Instances are the next layer of the instance is security group, where you allow or deny particular port numbers and particular traffic. Okay. And then everything will be in subnets. On top of subnets, we will have network ACLs where you have rules how to allow the traffic and all, and then routing table, which subnets to communicate and which networks to communicate. And there you can have VPC. See, this here there is a router symbol, but you will not have any physical router here. Okay, it is just everything is virtual. And here is virtual private gateway and internet gateway. These are the two things where you route traffic outside or internally. Okay. Internet gateway brings internet inside the EC2 instances. We will check in detail when we learn about virtual private cloud. So this is the typical diagram. Do you have any doubts up to here about VPC or EC2 or anything up to here? Okay. So this is VPC peering. So the main question you get about VPC peering is, in this diagram, all the VPCs are paired to VPC A. Okay, that means once peering is established, VPC A is able to, in this example, VPC A is able to communicate with all the other VPCs. But it doesn't mean that VPC B can access VPC C. There is no communication between VPC B and VPC C. Don't think like that communication will happen B to A and A to C. No, B cannot communicate with C. So this is the main question you will be asked when it comes to pairing. Normally people will ask like that, how will you pair two VPCs in AWS? Once it is done, they will ask you, and they'll give you the scenario like this, and they will ask you if VPC B can communicate VPC C. In order to make the communication possible, you have to pair VPC B and VPC C separately. Okay, remember that. And this is storage. This is storage. In storage, you can have multiple things. For example, as I said, elastic block storage is a storage which you will attach to EC2 instances to install operating system. Actually, whenever you launch it, it takes EBS volume, but you just have to mention how much GB you want, and it installs the operating system and comes up. And if you want any additional disks for storage, you can simply attach EBS volumes separately as additional drives. Okay, EBS is a raw unformatted external block device that you can attach to a single instance. EBS volumes are highly available and reliable storage volumes. Okay, and EC2 instances store, this is temporary the EC2 instances storage, we call it ephemeral drives. Ephemeral drives are, you can see in the diagram, right? This is instance store, instance A and instance B. Below that you can have ephemeral drives, and you can have this vertical AWS EBS volumes, and you can have S3 buckets. Okay, let me explain. These ephemeral drives are temporary drives. Whenever you reboot your machine, all the folders inside these drives will be deleted. Okay. Mainly, these ephemeral drives are used for temp locations. Okay, temporary locations. For example, if your application is generating many temporary files to use it internally, so we select that path to ephemeral drives, so that whenever we restart, these ephemeral drives will delete all the content inside that. And EBS volumes are used for installing operating systems and storing data and creating file systems. Okay, see here, for ephemeral drives it says data will be lost on stop or termination of instances. Okay, and simple storage service, which is also very important one, we'll have a separate session on this. Simple storage service, we call it S3. S3 is a repository for internet data. S3 provides access to reliable and inexpensive data storage infrastructure. Actually, the main thing is S3 is an object-based storage. That means it saves files, that's it, like your pen drive. Not pen drive, it's like a Google Drive or Dropbox. Dropbox is the first company which used S3. It was a startup which used S3 to make it a big success. Okay, so you cannot install, remember this, what is the difference between EBS and simple storage service is you can attach EBS volume to your EC2 instance, but S3 cannot be attachable, cannot be attached to any EC2 instance. And you can format and create file system on EBS volume, where you cannot format or install any application on S3. It is called object-based storage. S3 is object-based storage and EBS is block storage. Object-based storage means you can save files and download and upload. That is it. You cannot do anything else. Okay. So if you have any backups, anything like that, you can just save on S3. Okay, we will discuss more about S3 in later sessions. And remember that the difference between EBS and S3 is you cannot create file system on S3 and you cannot attach S3 bucket to any EC2 instance. Okay, it is object-based storage. Right, these are the storage types. We discussed about three. One is EBS, one is ephemeral, and one is S3. Okay, right. So relational database service, which is very important one, which gives us database service. RDS is a web service that makes it easier to set up, operate, and scale a relational database in cloud. So actually, normally, as I said, you need to have a server and you need to install MySQL or Postgres or MS SQL application inside that. You have to renew the license and you have to create databases, and then you will be able to access that database. But here you don't need to worry about what I say, operating systems or backups, how it runs and all. AWS will take care of everything. You just have to launch the RDS instance and it will give you an endpoint, that means hostname and username and password. You will just simply connect to database and do whatever you want to do. Its capacity can be resizable. You can increase or decrease the capacity of the RDS instance, depends on the load. Okay, RDS is more cost effective than the maintaining physical server. Remember that if you are maintaining any physical server, you have to pay for hardware, you have to pay for operating system and license, and you have to pay for our database license, and then you will use it. It is very costly affair. And you need one person continuously monitoring the RDS, database server. But here you don't need to worry about any operating system or renewals, any or backups. AWS will give us all the uh, things we need. And RDS manages backup software patches or automatic failure detection and recovery. So it is very easy. And SQS is another service which is the first service launched by AWS. Okay, SQS was the first service launched by AWS. Normally, what I say is SQS is a simple queuing service. That means, for example, think this way: um, people are uploading few files. Okay, you have so many employees, 100 employees are uploading uh, some files, some documents to their application. Okay, in that they'll create a queue in AWS, and from EC2 instances, for example, they are uploading from a web server in this example. So actually they call at a time if 10 members are uploading uploading files, but this server should process that request one by one, right? In that case, what happens is it goes to queue. Everyone will be in queue. Their uploading is still in progress. So once it is done, once it reaches to processing servers, this queue system will send one by one. Once the process is completed, the processing servers will send the queue back again, and it will delete the queue. It will give the same information to web servers to start the next upload and deletes the completed queue. You got my point? So it's simply a queuing service. A processing server can do only one task at a time, okay, or multiple tasks, for example, 2 tasks at a time. But what this queue will do is it will give one message to that particular processing server. Once it is completed, it takes the acknowledgement and it gives the message to web server that the process is completed and go for next one, and this queue will be deleted automatically. You got my point? So that is how it works. And yeah, CloudWatch. CloudWatch is nothing but a monitoring tool in cloud and log analysis tool. I mean, not tool, it's a service. Okay, CloudWatch monitors your AWS resources and applications you run on AWS in real time. In real time scenario, what happens is you need to monitor all the applications and servers. That monitoring means how much resources are being utilized, okay, how much response time, how much delay is happening, at what time my traffic is more. All these things comes under monitoring. So CloudWatch will give you a matrix based graphs so that you can understand how many database requests we got, how many connections are established, how much CPU is being utilized. All these things are being monitored with CloudWatch. So CloudWatch alarms send notifications or automatically make changes to the resources you are monitoring based on rules that you define. So for example, I can set alarms for that such a way that if my CPU utilization reaches more than 85%, then alert me. That means it will send me emails or SMSs. Okay. So in that case, if I get an email, I'll immediately jump onto the server and check for the performance and fix the issue if there is any. And also we can have system custom logs available to our development team. For example, if there is one issue going on production environment. We don't allow developers to log into our production environment. So what we do is we configure CloudWatch logs so that developers will log into their AWS account and check the logs. These logs will be in sync with CloudWatch. Okay, instead of logging into server, they can see all the logs and fix the issues through CloudWatch. It gives you system-wide visibility to resource utilization, application performance, and operational health. Okay, so you can monitor everything. How healthy is the servers or and this depends on that. Depends on watching your servers, monitoring your servers for 1 or 2 weeks. You can adjust the capacity of the server. For example, if it is consuming more resources all the time, you can simply increase the capacity of the server, or you can reduce the utilization by changing your application or anything. Okay, if you see the diagram below, it explains that the resources that use CloudWatch and your customer data, and this Amazon Cloud inside that green boxes, you can set the matrix. These are all metrics for CPU utilization, okay, hour and week count, CPU percentage, etc. Okay, and if it reaches peaks, that CloudWatch alarm notifies through SNS. SNS is a simple notification service which sends notifications to people or to applications. Okay, in applications, what we say is, after one task completed, send a notification to another service so that it will start another application. Sorry, another process. You got my point? For example, let me tell you this way. You are making a purchase on Flipkart, right? Normally what it does is, whenever you hit some button, it will go to your payment gateway's side. So there needs one API call or any integration, right? For example, we need to send a message to our bank's or gateway's website. So once you hit that, with this information, it sends a notification that this guy is want to purchase this product for this much amount, and then the process will start there. And once it is completed, it sends one more notification to our API, and it will complete. It will be completed. This is just a simple example. You remember that is how notification service, simple notification service work. But in our case in CloudWatch, it will send us one notification whenever it reaches, see, for example, CPU utilization to met threshold. Threshold is where I set at 80 or 90. If it reaches 80%, then it gives me the notifications, or it will go to auto scaling group. For example, as I said, if it reaches more than 90% CPU utilization, it goes to auto scaling group and it launches a machine again, a new machine. Okay, all these things will be monitored using our management console itself. Okay, this is very important topic, and most people ask you in interview about this one only. Okay, you will definitely have, if you say you are AWS admin, people will ask you about IAM, Identity and Access Management. IAM is a web service that helps you securely control access to AWS resource for your users. So all user accounts are created in AWS, IAM itself. You can grant permissions to different people for different resources. You can add two-factor authentication to your account and to individual users for extra security. Two-factor authentication is nothing but a physical device or a virtual device like Google Authenticator. After logging into your account, you have to enter some security code using that device. You can search with multi-factor authentication device. Let me search it for you. So multi-factor authentication or two-factor authentication device will look like this. Okay, it generates a random number every time, like your OTP. Okay, OTP. Then after entering your username and password, it will ask for this number. So first of all, you have to register this kind of devices with your AWS IAM account, and then it logs you in. And one more thing is Google Authenticator, which is a virtual one. You can have mobile app like this. You can have mobile app like this on your mobile, and you will connect this mobile app with your AWS account. So it generates randomly random numbers. So you have to give random number there in your AWS account so that it logs you in. So you can try. You can have. You can create your own AWS account, and you can try different ways. Okay, and so that is two-factor or multi-factor authentication. Okay, AWS is offering IAM service for no additional charge. See, controlling you for user management, you can control anything, but it is not charging anything. So you can have any number of users and any number of security groups, any number of policies, but it doesn't charge you. You can create groups, policies, and roles, and then map to users as per your requirement. Okay. So what I'm saying is, you have policies. That means the policy defines which user is which user can access which resource. Okay, these are policies. And policies have groups. Groups are nothing but, see, remember this, most people are confused here with groups. Normally in Windows or Linux, group means group of users. But here it's not a group of users, it's group of policies. Okay, if that group is attached to any user, he will be able to he will have access as per the policies in that particular group. Okay, and role is also a group of policies, but it will be given to EC2 instances, but not users. So this instance will have access to other resources like RDS for database, SNS, like that. So remember that this is the main question you will get whenever you go for an interview. In IAM section, the main question is, what is the difference between group and roles? Groups are group of policies and roles are also group of policies. But groups are assigned to users and roles are assigned to machines. So that particular machine will have access to other resources. Okay, we will check this practically in detail. And one more thing, I didn't add that slide, but ECS. ECS is EC2 container service, which is used for hosting your Docker container onto the AWS. Okay, we will have that one also in this session. Okay, do you have any questions till now, how it works and all? I want you to create one AWS trial account for yourself so that from tomorrow you can follow my, I mean, follow my sessions so that you can practice by yourself. So that EC2 account, AWS account is for free, and um, you will get 1 year free account. Depends on free tier services, but you have to use only free tier services. For tomorrow, I want everyone to create one AWS account for yourself, and we will continue our session from tomorrow. So let me go to AWS. AWS. Okay, if you see AWS, here you can have create account. It is just like email account, but you have to give your credit or debit card. Okay, here you see I'm a new user, so you can give your email address and password and go to sign up. I already have one. Okay, in this give your details, the correct ones, correct address, correct details. And one more thing is, it will ask you for your credit or debit card. It will not deduct the amount automatically, but you have to pay the bill, but you have to add at least one. Okay, so sign up for the AWS account, and we will continue our session tomorrow, from tomorrow. Okay, thanks for your time. Bye.